Good day. Thank you for this opportunity. My name is Diana Purwitasari and I come from Indonesia, Institute Technology 10 November ITS. Please allow me just 1 minute to introduce our university. Basically, our research vision in our laboratory is to make two server machine can understand each other but humanly as possible. In the previous video, the focus is about biomedical engineering research, such as detecting infant facial cry because they cannot communicate the pain, or lip feature extracting for speech training. However, in my presentation, the data is about text, so in text mining. Hopefully, if there is such a system that can have a collection of publication from researcher, and then the system can give some recommendation for the future collaboration. So that's the introduction of our laboratory and my research, and then I'm going to present my paper. So the title is Interdepartmental Research Collaboration Recommender System based on content filtering in a cold start problem. The content should be about background problem and then the proposed method, and the point is how to make the keyword representation, because for research collaboration recommender system, to identify topic is the most important part. And in our model, I'm going to compare 4 different approach, which is matrix based and then graph based, and then next with discussion and conclusion. So why research collaboration is necessary? Because government usually gives some roles to the university lecturers to increase the research productivity level. So in the implementation, in real life problem, usually that kind of problem need multi-expertise solution. And that's why research collaboration is necessary. And it can be started within internal institution, between department. However, the problem is sometimes lecturers are busy and cannot have nice conversation, or perhaps sometimes they are a little bit unwilling. Why? Because in some department, to increase the research level, there is a practice that called inbreeding recruitment. Inbreeding means that the lecturer asks the graduated student, please come join the department and become the lecturer. And in that situation, it could be the lecturer is a little bit unwilling to have collaboration with other department. However, in that kind of situation, this is a cold start problem because there is no previous information about topic. So the challenge here in this paper is how to recommend research collaboration in a cold start situation. Our proposed method has 5 main process. Start with the collection of student title, student thesis, but in this experiment we focus only on title, not the abstract, not the body, not introduction, just the titles only, and usually it's just 20 or less than 30 words. And then from those titles, the first process is to extract the keywords, or we call it here topic keyword representation, and then model the keyword to identify the topics, and we use clustering based approach. And then for the objective is to have recommended topics and hopefully recommended lecturers. But in this cold start problem, there is no ground truth. So in this proposed system, we also have some methods to generate validation lists. Like in the previous slide, the focus for our comparison is there is 4 types, which is the standard, the classic is term frequency matrix based, and then to reduce the dimension using standard latent semantic indexing, and then with recent research about word2vector, we also make some experiment on this one. And then to compare with the matrix, we also use with a graph approach. So for first approach with using minimum spanning tree, this is a graph version. Actually, this is have some reference to other paper, but I forgot to mention the reference. So basically, the lecturer have a collection of student thesis, but only the titles part. And then from this collection, create some kind of vector for the lecturer. And then all of those collection will be presented into a graph, and then cluster the lecturers by using a standard cosine similarity between factor lecturer of lecturer 1 and lecturer 2. The result is cluster of lecturers, not cluster of topics, but cluster of lecturers. For M2, M3, M4, the result is cluster of topics, and then we are going to compare the results. The second approach, this is a standard term frequency weighting. The vector also 2 kind of vector. First is vector of lecturer, and also all of the theses are going to represent as a matrix. And even though here is there is a graph, but actually this is just abstraction. The node in the M1, the node is a lecturer, but here the node is a student thesis. And then do some standard clustering with Cummings clustering, and the result is a cluster of student thesis. One cluster is assumed as a one topic, and here the representation is, for example, in faculty X, department Y, they are going to have 10 topics, and then the notation should be TP X Y1 and so on. So here it means that in one department there is 10 important research topics. After knowing in each department the most important topics, and then the next is mapping for each lecturer from his or her own department to know whether the lecturer interests on certain topic or not, and also the comparison in other department. So this will be going to recommended for collaboration. So basically, in M2, M3, and M4, the collection data is student thesis. The 3 most important part is matrix of term matrix, vector of lecturer, and also matrix of sentence, long sentence, and the data 1 are going to transform into word to vector, while data 2 and data 3 are going to transform into M2 as mentioned before. M3 is the same with M2 but transform first with latent semantic indexing. So this is the M3 latent semantic indexing. The standard term matrix transform into latent topic. In M2 there is clustering process, but here in latent, because the standard definition of SVD, singular value decomposition, it's already has been decomposed from words, this is words, into latent topics. So there is no need for clustering process. Just for to make it rather different, the result of M3 is cluster of latent topics, not topics. The same with M2, there is a mapping process for each lecturer to his or her own department and to other department. Okay, and the last is for M4, word to vector approach. The data is not vector of lecturer, not term matrix, but just a matrix of student thesis. And then with process from word to vector, I use Python GenSim library, and then to get the word embedding matrix, and the size should be index words, and then expected position for phrase possibility. So for mapping a little bit different in M4. So the raw data is thesis 1 and thesis 2. In M2, for clustering thesis, just using Cosin similarity between thesis 1 and thesis 2. But here, in M3, latent semantic indexing, just use latent semantic index matrix to convert matrix vector of thesis 1 into LSE projected. But here in word vector, the step a little bit different. So for example, in thesis 1 there is 3 words, and thesis 2 there is 2 words. To know the similarity between those two titles, make combination word vector from word embedding W1 to W2, W1 to W3, and W2 and W3. So it looks like this, and then make Cosin similarity, and then average all of this Cosin similarity to get the result similarity between student thesis 2 and student thesis 1 based on approach M4, word to vector. Okay, after I got the similarity, and then the next process just the same as Cummings clustering. Okay. For validation set, as I mentioned before, this recommended system has a special problem, which is cold start problem. There is no information about lecturer preference topic. That's why the validation set should be generated. Standard research on recommender system, especially on academic research, usually use a DBLP dataset. And for DBLP dataset, there is already grown through. For example, researcher A likes topic B or not. Okay, I just skip the process. So, and then for our dataset, we use our internal university repository. There is about 14,000 and then 900 lecturer, and the title should be composite between Indonesian and English. Okay, the discussion, let's say here F means there is faculty 1, faculty 2, faculty 3, faculty 4, and faculty 5. This is the precision. And you can see here, this is M2, M3, and M4. And for the approach for term frequency, it cannot give better recommendation. It's better to use representation for projection, transformation. I mean, there is a LSE and Virtu vector. So this is a little bit higher precision compared to IDF. And then, however, the next question is which one is better, LSI or Virtu vector? Okay, just skip to the last. Here just observe into one department, and we can see if using IDF model, this is impossible because this red node is a one lecturer. The other node is mean other lecturers from other department. And this is not real in the real life problem because one lecturer impossible to have collaboration with a lot of lecturer. This is more real and this is also more real, but from the checking in validation set, LSE model has better precision than Virtu vector. So the conclusion, this proposed system is works, and for the next future works, I'm going to have experiment with university, but not technology. Our university is technology oriented, so perhaps there is variation between economy or law and other things. Thank you for the time.
I'd like to open the floor for discussion. Any question or comments? So I have a question. So with your proposed technique and explain the research collaboration, and maybe your study will recommend maybe researchers to other research.
Yes.
And this is this is recommended based on the student's thesis title and the abstract or information. So how do you evaluate your proposal methods usability? How do you?
Without problem, so there is no ground truth. So first we use a sample data set. So simple data set, just two department, information technology and electrical and system information, and then we do the mapping, and then get the result. And there is some our respondent to check the result, which one is better or not, and then we get the threshold. So we use the threshold to separate the better recommendation and not for whole institution, but we start just in 2 or 3 departments. Yes.
You extend more double department or?
Yes. Our university have 5 faculties and about 20 something department. But for because to know the separation between which one recommended topic or good recommendation or bad recommendation, we have to know the threshold. So it's impossible to. It's a little bit difficult to get manual checking for all whole department. So we just use 2 or 3 department, which is in my department is informatics. So only focus on informatics, and the related is information system, electrical, statistics, and then just have some correspondent. Correspondent is a lecturer, but senior lecturer, so they know which one is better or not.
Did you try to apply your method to any researchers?
Not yet. Not yet. Yes.
Any other questions or comments? If there are no other questions or comments, I'd like to close the session. Thank you very much for your attention and your participation.